CIST 2612, Chapter 3, Data Acquisition. In this chapter, we're going to look at the digital storage file formats. We'll look at the ways to determine the best acquisition method, describe contingency plannings for data acquisition. We'll explain how to use acquisition tools, how to validate acquisition data, look at RAID acquisition methods, explain how to use a remote network acquisition tools, and also other forensic tools that are available for data acquisitions. So we'll start off, we're going to the three following storage formats are going to be used to store digital evidence. Our three formats are raw format, proprietary formats, and advanced forensic format. So start out looking at raw format. The raw format, it's a data acquisition format. It creates a simple sequential flat files of a suspect's drive or data set. What this does, it makes it possible to write bit strings of data to files. The advantages of using a raw format, these include using having fast data transfers, the capability to ignore minor data reads, errors on the source drive, and also most computer forensics tools can read a raw format. Disadvantages of using a raw format, these include that it requires as much storage space as the original disk or data, and also the tools that are used might not collect marginal or bad sectors in the raw format. When we talk about proprietary formats, we have to think that most forensic tools are going to have their own formats. Now we do have some options, features options by proprietary formats. Those include the option to compress or not compress image files. They can split an image into smaller segmented files. They also have the capability to integrate metadata into the image files. Disadvantages from using proprietary formats include the inability to share an image between different tools. And also you can have file size limitations for each segmented volume. Now, of all of the proprietary formats for image acquisitions, expert witness compression format, that is currently the unofficial standard for proprietary formats. The advanced forensics format, it's an open source format. So it'll store image data and metadata. File extensions for this include the .afd for segmented images files and a .afm files for the metadata. This was developed by Simpson Garfinkel. The design goals of this was to produce compressed or uncompressed image files, have no size restriction for disk to image files, provide space in the image file or segmented files for the metadata, have a simple design. It's open source for multiple computing platforms and OSs, and also offer internal consistency checks for self-authentication. As I said, the advanced forensic format is an open source format. So regardless of how we store it, we have to consider the best acquisition method. So we have two types of acquisitions. We have static acquisitions and live acquisitions. Static acquisitions, that is a method that's used when a suspect's drive is write protected and it cannot be altered. Now, if the disk evidence is preserved correctly, static acquisitions are repeatable. Live acquisitions are used when a suspect's computer can't be shut down to perform a static acquisition. We're also going to look at 4 methods for data collections: creating a disk to image file, creating disk to disk, creating a logical disk to disk or disk to data file, and also creating a sparse data copy of a file or folder. Now, determining on which the best method to use will depend on the circumstances of the investigation. So when we look at these acquisition methods, creating a disk to image file, with this, it's the most common method, and it does offer the most flexibility. You can create more than one copy, and the copies are going to be bit for bit replications of the original drive. This is also compatible with many commercial forensics tools as well. The creating a disk to disk, this is something you would use when disk to image copy is not possible. And the tools can be used to adjust the disk configuration. And some of the tools are in-case or X-Wave. Logical acquisition or sparse acquisition. These can take several hours. Logical acquisition captures only specific files of interest to the case. Sparse acquisition collects fragments of unallocated or deleted data. This is something you would use for large disks. It can also capture specific, logical acquisition, for example, can capture specific types of files, such as the Outlook PST file or RAID servers. So once again, logical acquisition, that captures only specific files of interest to the case or specific types of files. Sparse acquisition is also going to capture only specific files of interest to the case, but it's also going to collect the fragments of deleted data. Couple things to consider when you're making a copy is the size of the source disk, the compression method. Maybe a lossless compression might be useful. Digital signatures, use digital signatures for verification. Working with large drives, like I said, you may use the lossless compression. Whether or not you can retain the suspect's drive is also something you would consider. Also, the time you had to perform the acquisition and where the evidence is located. We also need to make a contingency planning for image acquisition. So we have a list of considerations here to take to prevent copies of evidence from being damaged or lost. We want to make sure that we duplicate the evidence copies. So we create a duplicate copy of the evidence image files. You want to make at least 2 images of digital evidence, and also use different tools or techniques to create these. You want to consider the host protected areas of the drive as well. Maybe use a hardware acquisition tool that can access the drive at the BIOS level. Now, when we talk about host protected areas, that's an area of a disk drive that's reserved for the booting, utilities, and diagnostic programs. This is something that's not going to be visible to the computer's operating system. We also may have to deal with encrypted drives as well. So, for example, the whole disk encryption. That feature in Windows is called BitLocker, and it makes static acquisitions more difficult. And these may require users to provide a decryption key. Now, what the whole disk encryption does, it performs a sector-by-sector encryption of an entire drive. So each sector is going to be encrypted in its entirety. It makes it unreadable when the copies with a static acquisition method. There are some acquisition tools for Windows that we do have some advantages and disadvantages for. Now, the acquisition tools from Windows, the advantages of these is it makes acquiring evidence from the suspect's drives more convenient, especially when we're using these with hot swappable drives. Disadvantages is that we must protect the acquired data with well-tested, write-blocking hardware devices. The tools can't acquire data from a disk hosted disk host protected area. And also some countries haven't accepted the use of write blocking devices for data acquisitions yet. We can also use a mini WinFE boot CD and USB drives. The mini WinFE, and it enables you to build a Windows forensic boot CD, DVD, or USB drives so that connected drives are mounted as read-only. So what this does, it builds a, when using this Windows utility, boot utility, it has a modification in the Windows registry file so that the devices are mount only. Now, before booting a suspect's computer, you want to make sure you connect your target drive. And after when mini WinFE is booted, in there you can list all the connected drives and alter your target USB drive to read-write mode. So there you can run an acquisition program. Now, if you're creating a mini WinFE boot CD or USB drive, I want to point out that you will need a Windows installation DVD as well, and also an FTK imager or FTK imager Lite or X-Ways forensics will need to be installed on the workstation as well. You can also acquire data with a Linux boot CD. Now, Linux can access the drive. It is mounted with older Linux versions. The newer Linux and Windows operating systems, they're going to automatically mount and access a drive. You could use the Forensics Linux Live CDs. With these, they don't access media automatically, which eliminates the need for a write blocker. Also on the Linux Live CD, the distributions for this, for instance, Forensics Linux Live CDs, they contain additional utilities. These are configured not to mount. Some of these include programs or names such as Penguin Sleuth Kit, Kali Linux, and others. When you prepare a target for a drive acquisition in Linux, okay, the current Linux distributions, they can create a Microsoft FAT or an NTFS partition table. You could use the fdisk or the mkfs.ms-dos commands. The fdisk command, it'll list, create, delete, verifies partitions in Linux, while the mkfs.ms-dos, that will command, those commands format a FAT file system for Linux. You can start on page 105 and follow the steps through there to learn how to prepare a target for acquisition if you have a functioning Linux computer. Also, if you're acquiring data with Linux, you can acquire data with the dd command, which is a data dump command in Linux. What that does, it allows you to read and write from media devices and data files. It creates a raw format file that most computer forensic analysis tools can read. There are some shortcomings of using the dd command. It does require more advanced skill than the average computer user might have. And also does not compress the data. Now, if you use the dd command and you use it with the split command, it's going to segment the output into separate volumes. You can see on page 112 in our text, when you follow those steps, it makes an NTFS disk on a FAT32 disk using the dd command. Now, the dd command, that's intended as a data management tool. It's not designed for forensics acquisitions. So we have the DCFLDD command. That's going to have these additional features. So it's going to specify a hex pattern or text for clearing disk space. It'll log errors to an output file for analysis and review. Use several hashing options. It refers to a status display indicating the progress of acquisition in bytes. We'll split data acquisitions into segmented volumes with numeric extensions. It also verifies acquired data from the original disk with metadata. Some of the other ways you can capture an image is with the Access Data FTK Imager Lite. This is included on the Access Data Forensic Toolkit. It's designed, it allows you to view evidence disk and disk to image files. It's also going to make disk to image copying of evidence drives at the logical partition. At physical drive level, you can segment the image file. It can also image RAM of a live computer. You can, now the evidence for this drive must have a hardware write blocking device, or you can run it with a live CD, such as MiniWin FE. So we see an example here on figure 3-2 of the main window for the FTK Imager main window here. Now, as I said, it can't acquire a drive's host protected areas. It must have a write blocking devices. And to use the write blocking device, you follow these steps. You boot to Windows, you connect the evidence disk to the write blocker, connect the target disk to the write blocker, start FTK Imager Lite. You would then use the create disk image, use physical drive option, and then we'll walk through the next steps. So in here we're selecting our source drive. Select the image type that we're going to create. We'll put the evidence information in, the case number, evidence number, a description, unique description, the examiner's name, and then notes. From here, we're going to select the image destination. So in here we have the image destination folder, the image file name, image fragment size. And then finally, we'll go through and create the image. You see that we have the elapsed time. Eventually, we'll have the estimated time left, and we'll have the progress as we're seeing this go through the process. All right, so validating digital evidence, this is probably going to be the most critical aspect of computer forensics. It's going to require using a hashing algorithm utility. These are going to be something that range from CRC-32, MD5, SHA-1 to SHA-512. Using Linux validation methods, we're validating the DD acquired data. We would use you can use MD5 sum or SHA1 sum utilities. This is something that should be run on all suspect drives and volumes of segmented volumes. When you're validating the DC, FL, DDD acquired data, you want to use the hash options, the MD5, SH1, SHA256, SHA384, or SHA512. With this, you also have the hash log option that outputs the hash results to a text file and we store with the image files. VF option, the verify option, that compares the image file to the original medium. For validating our data with Windows. Now, Windows has no built-in hashing algorithm for computer forensics, so we would need to use a third-party utility. We have commercial digital forensics programs that have built-in validation features. Each program is going to have its own technique. Raw format image files, they do not contain metadata, so we'd need to use a separate manual validation. That's something that we recommended for all raw data acquisitions. You can also acquire data using the RAID data acquisition. Now, RAID is a redundant array of independent disks. That's two or more disks combined into one large drive in several different configurations for special needs. Some RAID systems are designed for redundancy to ensure continuous operation if one disk fails. Another configuration spreads data across several disks to improve access speed for reads and writes. Now, acquiring data from RAIDs, it can be challenging and frustrating because of how the systems are designed, configured, or the size of them. Size is really going to be your biggest concern of the data. So redundance, as we said, the RAID computer configurations involving two or more disks. It was originally developed as a data redundancy measure. We've got different types of RAIDs configurations. RAID 0 provides rapid access and increased storage. Biggest disadvantage of RAID 0 is the lack of redundancy. RAID 1 was designed for data recovery, and it's more expensive than RAID 0. So we see an example of RAID 0, of how the file is split and stored on two different files, or two different drives. RAID 1 is more of a mirroring, so it's the entire file is saved on the two drives. As we said up here, biggest disadvantage of RAID 0 is the lack of redundancy, while RAID 1 is designed for data recovery. RAID 2 is going to be similar to RAID 1, so the data is going to be written to a disk on a bit level, has better data integrity checking than RAID 0. It was slower than RAID 0. RAID 3 will use data stripping and dedicated parity. Requires at least 3 disks. RAID 4 is going to be similar to RAID 3, but data is going to be written in blocks. So we can see an example here of a RAID 2 diagram. RAID 5 is similar to RAID 0 and 3. Place the recovered data on each disk. RAID 6 is redundant on each disk. RAID 10 are mirrored stripping. It combines RAID 1 and 0, provides fast access and redundancy. We talk about RAID 15 or RAID 1 plus 5. It's combinations of RAID 1 and RAID 5, and this is the more costly option. See an example of RAID 5 on the screen here. Now, when you're acquiring RAID disk, you got some main concerns that you have to address when acquiring RAID data. This includes how much data storage is needed, what type of RAID is used. Do you have all the drives connected? Do you have the right acquisition tools? Can the tool read a forensically copied RAID image? Also, can the tool read split data saves of each RAID disk? Now, copying small RAID systems on one large disk is possible. All forensic analysis tools can analyze an image then because they can see the acquired data as one large drive. Some vendors that offer RAID acquisition functions included the guidance software Encase, X-Wave Forensics, Access Data, FTK, Runtime Software, R Tools Technologies. Occasionally, though, you're going to run into a RAID system that's too large for a static acquisition. So when they're retrieving only the data relevant to the investigation, with a sparse or logical acquisition method is going to be your practical solution for that situation. You can also use remote network acquisition tools. In this, you can remotely connect to a suspect's computer through the network connection and copy data from it. These tools are going to vary in configurations and capabilities. Some of the drawbacks of acquiring data through the network include the antivirus, anti-spyware, and fireware tools. They have to be configured to ignore remote access, or they can be configured to ignore remote access programs. Also, if the suspect can only easily install their own security tools that will trigger an alarm to notify them of remote access intrusions if they have administration rights on their computer. Some of the tools we can use for remote access include ProDiscover. The ProDiscover incident response functions, what it does, it captures volatile system state information. It analyzes current running process, locate unseen files and processes. It can be used to remotely view and listen to IP ports, run hash comparisons, and also create a hash inventory of all files remotely. With this, the PD server remote agent, that's the ProDiscover utility for remote access, and this needs to be loaded on the suspect's computer before remote connection can be established. So the installation modes to install this is a trusted CD, pre-installation, or pushing out and running it remotely. PD server can also run in stealth mode. So you can change the process name as well, so it appears as an operating system function. The remotes offered by ProDiscover, these include password protection, encryption, secure communication protocol, write protected trusted binaries, and also use of digital signatures. If you want to use in-case enterprise to record or to have a remote acquisition features of it, these include search and collect internal and external network systems, and you can use this over a wide geographical area. You can support multiple operating systems and file systems. You can use it to triage to help determine systems' relevance to an investigation. And you can also perform simultaneous searches for up to 5 systems at a time. If you use RTools RStudio for remote acquisition, this is a suite that's going to be designed for data recovery. With this, you can remotely access network computer systems. You create raw format acquisitions, and it supports various file types as well, file systems as well. Another type of remote acquisition is with Whetstone US-LAT Pro. Okay, so this can connect to a network computer remotely, and it can perform live acquisitions of all the drives that are connected to it. You can go to their website to look at more information for US-LAT Pro. F-Response is also another tool that you can use for remote acquisitions. This is a vendor-neutral, especially remote access tool. It's designed to work with any digital forensics program. With this, it sets up a security read-only connection and allows forensic examiners to access it. There are 4 different versions of F-Response, and those are Enterprise, Consultant Plus, Convert Edition, Consultant Edition, and Tactical Edition. Now you have other types of forensic acquisition tools that are available as well. The Passmark software, Image USB, ASR Data Smart runtime software, Outlook non-investigator imager, non-imager, RX imager, and SourceForge. All right, Passmark has an acquisition tool that's called Image USB for its OS forensic analysis product. To create a bootable flash drive for this, you would need Windows XP or later and the Image USB downloader from the OS Forensics website. And this allows you to create a bootable flash drive. The ASR Data Smart, this is a Linux forensic analysis tool. It can make image files on suspect's drive and can produce proprietary or raw format images. Capability of this is it does data reading of bad sectors. You can mount drives in write protected mode, or you can mount the target drives in a read-write mode. You also have compression schemes that can be used to speed up acquisition or reduce the amount of storage needed. Using runtime software, this is a utility that can be used for FAT or NTFS. This is a shareware program. It's used for data acquisition and recovery. Features this, it creates a raw format image file. You can segment the raw format or compressed image for archiving purposes. It also allows network computer drives, access to network computer drives. The Outlook Investigator IX Imager. This runs from a bootable floppy or CD drive. It's designed only to work with Outlook IX. It can acquire single drive or RAID drives, and it supports the IDE drives, SCSI drives, USB, FireWire, multiple types of drives. SourceForge, this provides several applications for security and analysis and investigation. You can look at their website for current tools. It also has a window version of the DC FLDD. Is SourceForge-DC FLDD. I have their website open here. As you see, they have a lot of different options for tools that you can search through. All right, to sum up Chapter 3, forensic data acquisition. They're going to be stored in 3 different formats: the raw, proprietary, and AFF. We have 4 different ways that we can acquire our data: disk to image, disk to disk, logical disk to disk or disk to data, and then the sparse data copy. We have several different tools available for acquisitions. Remember that the type of acquisition that we use is going to be dependent on what is needed for the case. Also, make a copy of your acquisition. The preferred Linux acquisition tool is the DC FLDD, not just the DD, the data dump. You want to use physical write blocker devices for acquisitions. You need to determine the type of RAID you're working with to acquire the RAID disk, and then determine which type of tool you need. And remote network acquisition tools, they're going to require installing a remote agent on the suspect's computer. All right, so that's going to wrap up Chapter 3. Be sure to complete your assignments, put your labs, and if you have any questions, send me an email.